In this video, we're going to have a look at more of the database editors. As I said in the Sites Table video, the database editors give meaning to the data stored in the data files, and until you engage the editors, Hilltop doesn't know much about your data at all. Firstly, I'll take a minute to explain what data sources and measurements actually are. Hilltop software works on the notion that you travel to a site and take a measurement. However, some people often measure the same thing twice, so we need to be able to define which measurement is which. Take stage for example. This is done by a water level recorder mounted on the riverbank. Staff will come along and do a stream flow gauging in order to calculate flow. So now we have two measurements of stage. Hilltop uses the data source to distinguish between the two measurements. Stage from the recorder has a data source of water level, and stage from the stream flow gauging has a data source of gauging results. Now that we've cleared that up, let's have a look at the data source editor. Open the editor and select an existing data source from the list, or add a new one. If you add a new data source, you can name it and create a measurement. This is useful because you are mostly wanting to create a measurement and have Manager look after the data source definition for you. Click OK. The new measurement is created, and if you click Measurement, it will open the Measurement Editor where you can make changes to the measurement. We'll come back to the Measurement Editor shortly. Let's go back to the Data Source Editor. You can ignore the Data Source ID. It's a number assigned by and used by the software. Hilltop software processes the data in a particular way according to the data type. There are many options, including this one that tells you not only if an alarm has been on, but for how long. These ones are for rain gauges, where the logger just reads the time the bucket tips, and Hilltop will then add zeros where it is not raining. And this one is for wind direction, where the software takes into account where the wind goes through north and won't add any unhelpful lines to your graphs. All the data types are defined in the help manual. Most data is a set of numbers stored against time, in which case you'd select simple time series. The interpolation method tells the software how to calculate values at times between those stored in the file. Instantaneous is the most common, and in this case the software will join the dots, so to speak. Discrete doesn't assume anything about what happened between readings, and you'd use this for water quality grab samples. Histogram is used for computed averages like mean daily flow. Use incremental where you want a total over an interval, like for rainfall data or metered water use. Event is used for gate settings, where a position is recorded and it stays constant until the gate is moved and a new value is then entered. Use quasi-continuous when the data has been collected so sparsely that it can't be considered a continuous time series. The discrete method is used to compute statistics, but the data is drawn on a graph as continuous. Group name on a tree is an optional field for grouping data sources together on the tree control. Manager usually shows the sites and measurements on the tree control, but you can elect to show the data source. This is useful if you've got a multi-item data source like gauging results. You can enter a comment here if you wish. In these fields, you enter how many items of data were measured at the same time. Actual data is that comes from a logger or a grab sample. In this case, I have 2 items. I update the number and then press Tab to update the table. You click in the appropriate box to select the format for each item. You would usually choose floating point as the data will be stored in its natural units. Date is for where you are recording a date and time to match the clock on a data logger. The Check Data field works in the same way and is for data that is measured independently of the logger. Let's now have a look at the Measurements Editor. As I was saying earlier, a measurement is a single item of data that is always associated with a data source. So we first need to select the data source and then select the measurement. You can add a new measurement here, Or use Quick Add to create a measurement and assign a data source to it. This is handy for water quality data where the data source isn't so relevant. You need to define your measurement. Mine is actual data with an item number of 1 as it's a single item of data. I would select this if my measurement was calculated by passing the data through a set of rating curves. For example, if I applied a rating to convert stage to flow, this would be rating set 1. And if I then applied another rating to convert flow to sediment concentration, this would be rating set 2. You can store ratings in floating point. Virtual measurements are calculated by reading data for other measurements and doing arithmetic on the data. I discuss virtual measurements in another video. You can store the measurement as a subvariable, which is a separate time series that has the same data source as the main variable, for example data from a backup recorder. Tick here if your measurement describes an item in the check data. And tick here to say that the data source measurement combination you're presently editing is the one to use if you're using your data in a situation where no data source is given. There is again the option to specify a short name. And like data sources, you can group measurements together on the tree control too. You can say anything you like about your measurement here. Here you need to enter the units for your measurement. My stage data is in millimeters. However, if I wanted to look at stage in meters, I would need to enter meters here and a divisor of 1000, and the software will convert the measurement. Here you can specify the number of significant digits or the number of decimal places you want displayed. It is useful to display volume for measurements such as flow, which changes flow in cubic meters per second to volume in cubic meters, and you'll need to do this if you want to do any volume calculations. If I select flow as a measurement, you'll see that the conversion is done here. There are icons on the tree control to help identify measurements, and you can add your own 16 by 15 pixel bitmap here. You can choose the colours Hilltop uses when graphing your data. Select the colours for non-detects here, and you can instruct the software to use different colours according to quality level of the data. This blue will be used when the quality marker is 0 or where there is no quality information for that value. Then you need to specify a numerical range for your quality codes and select your colours. If you want to use the colours defined by National Environmental Monitoring Standards, click this button here.